Emah, the future of humanoid robots. It's not just another machine, it's a game changer and a visionary creation that's setting new standards in the world of humanoid robots. Hello everyone and welcome to a new engineering related video. Today we are delving into the fascinating world of humanoid robots and AI, and I'm beyond excited to introduce you to Ameca, one of the most advanced humanoid robots on our planet today. It was created and developed by Engineered Arts. If you want to get inspired and educated also about this topic, this video is for you. I have had the opportunity to meet the PhD engineer working on this project in the University of RPTU in Kaiserslautern in Germany, and specifically in RR Lab. And we are going to explore with him the incredible work they are doing with Ameca, or as they name it in the lab, Emah. Not only this, but we will also have a chance to make a demonstration on the robot, to see the robot while it's working. And now enough talking, let's get started after the intro. First of all, hi Sarwar.
Hi.
Thanks for having us today. You can first introduce yourself.
I am Sarah Paplu. Currently, I am a researcher at the Robotics Research Laboratory under the Department of Computer Science of the University of Kaiserslautern, London. I was born in Bangladesh. I studied computer science at the University of Chittagong. After my graduation in computer science, I started my career as a statistical programmer. So after 2 years of my job, I came back to academia. So I started as a lecturer at a private university in Bangladesh. And then I wanted to go ahead with my education with more studies. That's why I came to Germany to pursue masters. My specialization was artificial intelligence.
It was also related to humanoid robots, like the master thesis?
Yes, it was definitely related to human-robot interaction, and in the PhD, it was just a kind of extension of my earlier work.
You started working with Emah in the PhD. What was exactly your focus in the PhD, the focus of your research?
The main focus of my research was to apply some aspects from human-human interaction. In my case, it was personalized interaction. Let's say you are one individual and there is another individual, and we wanted the robot to behave differently depending on the characteristics that you have, depending on the history of conversations. Yeah.
Okay, that's really interesting. So I would think it's a good idea to maybe, if it's possible, to go to the office where the robots are.
Yes.
Maybe we can have a better view of the robots, yeah?
Yeah, sure, yeah.
Okay, so we are now in the office where the robots are present. You can see first there is Robin, I believe.
Yes.
Yeah, so this is what the robot that they started working with before.
Yes, this is the robot I started working with. Parallelly, I was also working on this robot. This is, as I mentioned earlier, the generic name of the robot is Ameca.
Mm-hmm.
But in our lab, we call it Emah because we have our own interaction system and we use this robot as a front end, yeah?
So can you give us more overview about Emah?
Emah is an interactive robot that establishes communication or interaction with humans with its multimodal sensor system. For example, here as you can see, these are basically cameras.
Yeah, cameras eyes, yeah?
Yeah, they look like eyes, but they are basically cameras, yeah?
Uh-huh.
But these are just high definition cameras, and also it has a camera here. This is HD camera, again, to see the person from different perspective. This is sometimes better, yeah.
Mm-hmm.
And also we have integrated this camera. This is a stereo vision ZED,
yeah.
2 camera from Stereolab. Basically, this camera is connected externally. The wire is connected to the external computer, because we are using the images captured by this camera for
work.
Yeah, for most of the scene perception or human perception tasks. By the way, the robot also has an embedded PC inside.
Uh-huh.
And this PC is mostly responsible for the movement or speech or these things, but they are not designed for computation, heavy computation purposes. So that's why we outsource most of the computation to our external computer.
So if I understand correctly, everything mathematically, everything you made like preceding environment, that stuff, everything you have to work on your own, and then you send that to the robot. So the robot itself, it has the tools that helps you, but it doesn't have this neural network stuff or
No.
yeah.
Even the natural language processing parts. So I can also show you the microphone, something like this.
Yeah.
Yeah, and then you can simply talk.
And this microphone is connected to the PC.
Exactly. So the signals captured by this module, and then it goes to the other computer, and then we analyze the acoustic signals. Yeah. Like for speech recognition and other natural language processing, like translation, generation of speech,
Yeah.
and so on.
So I see the whole body, but I don't think it's moving, yeah? It doesn't move.
No, this version is not designed
To
walk. Yeah, but maybe future we have another project. I think you have already seen downstairs.
Yeah.
The leg project, and yeah, if that is successful, of course we can
combine both.
Yes.
Yeah, that's really nice. So currently, what we can do with this robot? Like we have the movements for the arms, I believe. We have the movements of the face.
Yes.
So you want to make different expressions. You want to make different postures.
This robot is particularly reputed for its huge number of degrees of freedom. So currently it has 52 degrees of freedom in the entire body, and out of which 18 degrees of freedom are
18 degrees just in the face.
Yeah. So
Okay.
if you just tweak some parameters, and then we can make facial expressions. Similarly, if we tweak the joints, so the motors that are responsible, and it can also make nice like welcome gesture or hand waving gesture.
Also, like the touch, it really feels like a human. Like
Yes,
it's like a skin.
yeah, it feels like skin, but currently we have no touch sensor. So there is, as of now, there is no tactile sensors on the robot. But in the future, we have also planned to attach more sensors, because we humans have, as you know, 5 senses. Yeah. Currently, the robot has 2 senses: vision
and
audition.
Okay, so with all what you mentioned now about the technologies that we talked about, what do you think is the use? How we can use Ameca or Emah in its current model, its current situation?
Yeah, that's a very interesting question. These robots can later on provide personalized assistance to the person, because the robot to some extent knows about the person, the problem.
Actually,
and it can be
focus of your research. Yeah, like this is exactly a focus of your research.
Exactly. So for example, the other group that I can mention about is the children with autism. They also so this is as you know, is a spectrum disorder. But this is something that we can cure to some extent. Like if we pay more attention to the such kids, there are many research that shows if we teach these children some social norms, some social skills, like making eye contact or coming or getting involved in a conversation. So these robots, we can program these robots in a way that they can make interactions very interesting for the particular children, and also giving companionship to elderly people. So as you know, our society is now going in a direction where we have a huge number of elderly people, and healthcare is exhausted.
So such an advanced technology like this, for sure you faced also some challenges in your research.
Yes.
Can you share some of these challenges with us?
So in my research, initially I was, of course, investing a lot of time in the development of concepts, which of course comes from cognitive science, social sciences, and many more. Then of course we have to implement on the robot. But the challenge is we have to map some aspects of human-human interaction in a human-robot interaction scenarios. So this is sometimes from a cognitive point of view very challenging, because we cannot give cognition to the robot, but the humans have cognition, the robots have no cognition. So which means they have no mind on their own. These are, at the end of the day, they are programmable devices.
So what other challenges did you face?
Okay, so as you see, this system is distributed, meaning we have two computer systems running parallelly, and we have to make very fast computation, because the camera, let's say, is capturing images, it's going to another PC, we are computing or speech going through this microphone, and we are computing another PC, and then the control signals have to come to the robot very fast. Because in research I found in human-human interaction, normally we don't take more than 1.5 seconds to some extent. Yeah. So in our case, we tried to mimic this aspect of human-human interaction in terms of latency, and I achieved a latency of 834. So which means milliseconds, exactly. So less than 1 second.
So this is also important, like when we are talking, the robot, when it's reacting or giving a posture, it should talk and give the posture at the same time. I mean, there shouldn't be a lag.
No, there shouldn't be a lag, and in my research I experienced this, that if there is any lag, interaction is not so good.
Yeah.
Because let's say the robot is speaking, hello, and the gesture is coming after maybe 1 second, or maybe even 900 seconds or 800 seconds, it's terrible. Yeah. So we have to make it synchronous. So that's why we use a dialogue management system, and we can simply provide all the parameters in the dialogue manager, and then the robot gets all the control signals at the same time.
I believe after all this informative knowledge you gave us, maybe the viewers will be also interested to see some demonstration while the robot is working. So if it's possible, also we could try something with the robot.
Yes, sure. I can currently, as you can see, the robot is
shut down.
Yeah, shut down. So I'll turn the robot.
Yeah, sure. Thank you. So now we started the robot. As you can see, the robot is running, and we can see what you can see also on the screen. We will show you. So what we can do now.
So as you can see now, this is the interface. By the way, and here I just want to show some of the language skill of the robot. Let's say I cannot show all of them due to time constraint, but I can show you some of them.
Okay.
For example, let's say I am going to activate the speech recognition part, and the robot will understand my speech by the microphone, and then it will do as per the instructions.
Yeah.
Hello.
Greetings. I believe you were looking for some information about our lab.
Yes, I am looking for some information.
Okay, please let me know how I can be of use to you.
Do you have a name?
My name is Emah.
Hi, Emah.
Greetings. Are you looking for some information about our lab?
What are your skills?
I can recognize English and German speech. I have an internal speech generation system for both the languages. If required, I can translate English sentences into German. It is also possible for me to perform basic maths calculations. Moreover, I can correct basic grammatical mistakes, deliver synonyms or antonyms of specific words. I can also observe my interaction partners and the environment with my visual senses. By the way, I can also remember user-specific information for long-term interactions. Okay, keep going.
Translation, I can show you how it can be translated.
My name is Abdo. I am 26 years old.
Mein Name ist Abdul. Ich bin 26 Jahre alt.
So this is one of the
language skills. Yeah, there are many. Like I told you about. It can also check grammatical mistakes. It can find vocabulary for you. It can also fetch information from Wikipedia and so on.
So can we also see something about perception part?
Here you see. Yeah, I can show you also visual perception. So as you can see, if I turn on everything, all more or less aspects of visual perception, fearful.
And I can see there is no eye contact currently. If
Yes.
I look,
If you look, then it is saying eye contact. Yeah.
yeah, right. Now I'm not looking again. Yeah.
It's not eye contact. Yeah, it is also finding your proximity. If you go closer, it will.
So the distance.
Yes. Yeah, so it's now showing 160, 180, 205, yeah. And
Okay.
currently you see here there is
Number of
only
faces.
one face, and if I come inside the frame, there are two faces. Yeah?
Okay, yeah, that's interesting. What about the
Also, the
posture?
postures, you can do
Oh.
welcome gestures or something, yeah. So it shows
Right
now
hand raised.
standing normal, right hand raised,
Yeah,
yeah,
two hands.
and showing both hands
Yeah.
raised, leaning forward, yeah. And also it can understand,
It can read.
it can read, yes.
So from here, or is it
Yes,
far?
you can go closer. So it's saying Lucy, yeah?
Yeah,
Yeah,
it is reading.
yeah. So robot should also somehow understand your tone, yeah?
Yeah,
These are also very important aspects, like also your face, if it is showing any emotion, yeah? The system can also understand. So it can also understand the objects, as I told you earlier. So let's say if I run this household object model,
yeah,
so now the robot will start looking into it like it's finding a TV and there is two-person. So it's considering the monitor as a TV.
yeah.
And if I, let's say, bring this one here, it's saying this is a bottle. Yeah?
Yeah.
It's finding it as a bottle. And also, if you activate the scene captioning module, the robot will now describe the scene. Yeah, what it's seen. Like a group of people sitting at table with laptops. Yeah, it's quite
Fair enough.
fair enough. Just making an estimation. Yeah.
Yeah.
And if you activate, let's say, the fashion objects, it will look for sunglass and
We don't have something like this.
jackets or something. Yeah,
Okay.
if we have something. The robot should make very high level estimation of a person. Yeah. What is your name?
Here in the laboratory, I am known as Emah.
It's also measuring my average speech rate, average speech variation,
The energy.
energy.
Keep going.
So these are the aspects that we call paralanguage. Yeah, the robot estimates. And here, the right hand side, we are estimating the body activity. Since you are not doing anything, you have now negative
So
body activity.
if I move,
If you do more, it will come to the positive axis, of course. And then based on these features, the robot is now estimating that, okay, you are probably an introvert, you're self-centered and traditionally. Can you walk?
That's an awfully personal question.
so these are some facial expressions, yeah?
Yes. So like here, the robot is now smiling, as you can see.
Yeah.
Here it is giving a broad, like explaining something, yeah?
Yeah.
Or let's say the robot is getting surprised. It's trying to say, okay, try to understand, yeah?
Yeah.
And you should say, okay, please come closer. And showing some kind of anger, yeah?
Oh, yeah. Do you have legs?
I wouldn't think so.
What do you think is the weather today?
I think currently we have light rain and the temperature is 11 degrees Celsius.
Yeah, actually, that's right. It's raining currently. What is the area of a circle if the radius is 5?
We know the area of the circle is pi times radius squared. So, the total area of the circle, given the radius pi, is approximately 78.
So I guess that's it with the demonstration. Like, that was all with the demonstration, right?
Yeah.
Okay, thank you very much for your time. And thank you for this nice demonstration. I'm sure the viewers got more knowledge about the humanoid robot. So thank you so much.
Thank you very much. I tried to show you the major aspects, and I think it helps the
Yeah, sure.
audience to some extent. Thank you very much for coming.
Thank you. And that was all with this video. I hope you liked it. If you did, don't forget to like and subscribe to the channel. If you have any further questions, please let me know in the comment section. And see you guys in the next one.